السلام عليكم. في هذا الفيديو راح أشرح محاضرة الأسبوع السادس من مقرر Math111 قسم العلوم الطبيعية عمادة السنة التحضيرية بجامعة الامام عبدالرحمن بن فيصل بالدمام. هذه المحاضرة is about the radical and the rational exponents. The square root of real number. What is the square root of real numbers? Basically, the square root of any real numbers, as you know, for example, we have the square root of 4 equal 2. So the value of the square root under the square root should be positive. Okay, it should be positive. And the value given for the square root also should be positive. Okay, so why the square root of 4 equal 2? Because 2 to the power 2 equal 4. So that's why I can say that the square root of x equal y, because y square equal x. And for the negative square root of x, this is the negative square root or the negative square root of x. We can read it as this. So now how can we simplify the square root of x square? Basically, the square root of any values, the square root of any values x is actually the root by itself is a special case of the exponent. So I can write the square root as a power. So x equal here the square root of x square, I can write the square root as 1 over 2. Then I have this 2. Now, if I have power and then all to the other power, so I can multiply the power. So this would be x to the power 1 over 2 times 2. And now 1 over 2 times 2 is 1, so x to the power 1, which is x. So that's why the square root of x square equal x. Okay, so in general, the square, if this is non-negative number, but if it's any real number, so we have to put it under the absolute values to just guarantee that the value for the square root is positive, because it should be positive. So to guarantee that, we should put x under the absolute value. An example here, what is the square root of 144? So 144 is 12 to the power 2. So I can just replace 144 with a 12 to the power 2. Now we said that the square would cancel power 2, so we're left with 12. So same things with the root 1. You know that I can write 1 as 1 to the power 2. So I'll just put the square root as it is, and the negative as it is. So I put the negative down because here the negative has nothing to do with the square root. Okay, so I just put it as it is. So now the root will cancel the power. I will left with 1. Okay, since as I said, the square root or the root in general is a special case of the exponent, so all the rules of the exponent can be applied on the roots. So here I can just distribute the square root to the numerator and to the denominator. And you know 25 is just 5 to the power 2 and 9 is 3 to the power 2. So now I cancel the power with the root, so I'm left with 5 over 3. And you know that there is a condition for the values under the root. It has to be positive or non-negative value. Okay, so since negative 1 is less than 0, so that's why this value is undefined in the real number. Okay. So now for any real number x, what about the cube root of x? The cube root of x, we write it as the cube root of x. Okay, and here we are looking for we want to write x as y to the power 3. So any values, we want to write any values that is under the root as a number to the power 3. For example, here we have the third root of 0 equals 0 because 0 to the power 3 equals 0. Also, the third root of 8, you know that the third root of 8 is the third root of 2 to the power 3. So always write this number as any number to the power 3. So then cancel the power with the root and you're left with 2. Also, the third root of negative 8. So we can write 8 also here as 2 to the power, so the negative 8 is negative 2 to the power 3. Because you know in the power, in the odd power, the negative will remain. So this means that the power would cancel the root and we're left with negative 2. So in general, as you can see, the immediate sequence from the definition of the cubic root, that if we have the third root of x to the power 3, we have x. So for this all real numbers here, we don't care about the number, whether it is positive or it is negative or 0. So let's see this example. We have here the third root of negative 27. So I can write negative 27 as negative 3 to the power 3. If you don't know, you just can factorize 27 to 3 times 9, then 9 3 times 3. So you can write 27 as a 3 to the power 3. So now we would cancel the power with the root, so we were left with negative 3. Also for negative 125, so the third root of 125 is negative 5 to the power 3. So you would cancel this root with the power and you're left with negative 5. Okay, so now for this fraction, we can distribute the root to both numerator and denominator. So we have negative 27 over the third root of 1000. For the negative here, as I said before, we can write the negative outside like this, or in the numerator or in the denominator. So here, the third root of 27 is here. It is negative 3. And the third root of 1000, since 1000 is 10 to the power 3, so I could write 1000 as 10 to the power 3. Now I cancel the power with the root, I left with 10. Okay. D, the third root of 216. If the number is large and you don't know what to the power 3 equal this number, so you just go ahead and factorize this number. So 216, you know that this number is divisible by 2 since it is even. As you can see, the ones is even. So it is divisible by 2. So 216 divisible by 2, 2 divided by 2 is 1. Then we subtract 0, then we put this 1 down. 1 cannot be divided to 2, so I put 0 up and then I put the other number down. Now I divide 16 to 2, which is 8. 8 times 2 equals 1600. So the answer is 108. Now 108 is also divisible by 2 because it is an even number. And 10 divided by 2 is 5. 8 divided by 2 is 4. 54 from the times table, you can see that it is 6 times 9, and 6 is 3 times 2, and 9 is 3 times 3. So the factoring of the prime factors of 216 is 2 to the power 3 times 3 to the power 3. Okay, now I can distribute the root to both numbers here. Now I would cancel this root with this power in both parts. So I'm left with 2 times 3. I can also say that this is the third root of 2 times 3 all to the power 3. Then I just cancel also in this case. I will left with 2 times 3, which is 6. Here, 6. Okay. Let x be a real number and n be a natural number such that n more than or equal to. So in this case, we want to see whether we have whether n is even or n is odd. In each case, what should we do? If n is even, like for example, the square root of x or the fourth root of x or the eighth root of x and so on. So in this case, we're looking under the root, okay? If the under root is positive, so we don't have any problem, the value would be positive and everything is okay and defined in the real numbers. But if the values under the x, under the root is negative, the value of the root would be undefined as a real number. If n is odd, in this case, for example, if n is odd, for example, the third root of x or the seventh root of x, in this case, we don't care about x if it's positive or negative because it would be defined anyway. Okay? So in general, if we have the nth root of x, the sample, this one is the radical, and n is the index, and x is called the radicand. Okay, so another things, if n equal 2, we usually don't put the 2 above the root. We just write the square root without any number, and it's understood that we mean the second root or the square root. So the algebraic expressions that contain a radical or the root is called the radical expressions. Okay, and in general, if I have this case, as I said before, the root would cancel the power and I left with a. But this is for a special case if a is so we should be a little bit specific about n here. If n is odd value or odd number, then we can write x as it is. But if n is even, so we have to write x under the absolute values to guarantee that we have positive values. Okay, because for the even root, we should have a positive value. So let's see these examples here. We will apply this rule. Okay, so we get a look at the root here. If it's here, as you can see, it is odd. So directly we get to cancel the root with the power, and we're left with x. Okay, now the power here is even. So if the power is even, as you can see here, if the power is even, we get to have under the root without power and under the absolute values. Okay, so this is ready to be cancelled, but for the 16 is not ready, so we get to write 16 as a number to the power 4. So you know that 16 equal 2 to the power 4. So let's write the fourth root of 16, okay, times the fourth root of x to the power 4. This would be the fourth root of 2 to the power 4 times the fourth root of x to the power 4. And we can just cancel this power together with the root, and then we're left with 2x. Okay, so we can distribute the root, or also we can just write this one as, let me write it here, this as 2 to the power 4 times x to the power 4, then I write 2x all to the power 4. Then I cancel the power with the root, I left with 2x. So both ways is fine. Both ways is fine. Okay, now let's do next one. 81, same things. 81, we can write 81 as 3 to the power 4. And x to the power 8, since here we have 4, so I need 4, not 8. So I can write 8 as 4 times 2. So I put x to the power 2, then all to the power 4. Okay. Now I can write 3x squared all to the power 4 and then cancel the root with the power, so I left with 3x squared. Okay. Sorry, I forgot the fact that if the power is even, so we should put an absolute values, okay, around x. So the same things here, absolute values around x, but since x squared is always positive, so we don't have to put absolute values in this case, so we can write 3x squared. Okay, for the last one, same things we have here in even value, so we have to put, after we cancel out the power with the root, we should put under the root with an absolute values. Okay, so how can we simplify? We have here some equations. So same things, we can cancel the root with the power, we're left with x. But since this is even, so we put the absolute values. Okay, here we have a number that is not written in a power form, so we write 32 in a power form, which is 2 to the power 5, then x to the power 5. You know, 32 is 2 times 16, then 16 is 2 times 8, then 8 is 2 times 4, then 4 is 2 times 2. So you can see that 32 is 2 to the power 5. And negative 32 is negative 2 to the power 5. And I would recommend you to just keep on your mind 2 to the power 5, 2 to the power 4, 2 to the power 3, 2 to the power 2. Here is 32 also, 2 to the power 6, 16, this one is 8, this one is 4, this one is 64, also 3 to the power 2, 3 to the power 3, and 3 to the power 4, 9, 27, and 81. This is a popular powers. I want you to keep them in your mind. Okay. So going back to these examples, as you can see, I can write this as negative 2x all to the power 5 under the fifth root. Then I would cancel the root with the power. I would left with negative 2x. Since this is odd, so I don't have to put the absolute values. Okay, for this one, the fifth root of 243. Okay. So 243, you might not know like what to the power 5 is 243. Sorry, let me write it here. 243. This number is divisible by 3 because when we add the digit together 2 plus 4 is 6. 6 plus 3 equal 9. So when we add the digit together, we would have a number that is divisible by 3. So this number is divisible by 3. Okay, so 243 is divisible by 3. And you can divide this. 24 divided by 3 is 8. And 3 divided by 3 is 1. Now, 81, without even factoring 81, you know already that 81 is 3 to the power 4. So we have here 3 to the power 4 and here 3, so I can write this one as 3 to the power 5. Okay, so 3 to the power 5 and x to the power 15. I don't need 15, I want 5. And you know that x to the power 15 equal x to the power 3 all to the power 5. I can write it as this. Okay, because power to the power, we just multiply the powers. 3 times 5 equal 15. So I would write this x to the power 3 all to the power 5. Okay, now I can write this 3x to the power 3 all to the power 5. Now I cancel the power with the root, so I left with 3x to the power 3. Again, since the power here is odd, I don't have to put the result in the absolute values. Okay, now for this one, we have 7 and here we have 7, so it's ready. We don't have to do anything except that just notice that if this is odd, you put the under values as it is without absolute values. If it's even, we put the absolute values, but here it's not even, so I don't have to put the absolute values. So this is directly the answer. Okay, so this is just the rules of the radical. As I said, it's exactly same as the rule of the exponent. So as you can see here, we could just distribute the root to both numbers under the root if they are multiple, or in the division form. So we could distribute the root to all the values under the root if they are if we have a product of numbers. Okay. So here we have an example. The m to the power 9, the square root of m to the power 9. So as we said, if there is nothing written here, it means 2. Okay, if nothing written here, it means 2. So I need these values to be 2, but there's no way I have 9 as 2 times something. So what should I do here? I will divide m to the power 9 to m to the power 8 times m. Okay? If you can remember from the first lessons that in this case, if there is two base, we have the same base, multiply with each other's, and the power is different, I can add the powers. So this is power 1, this is power 8. I can add these two powers to give me the 9. Okay? So go ahead now and just divide your 9 to a number that is divisible by the value that you have over here, which is 2 in this case. Okay, so here the square root of this one. Now I can divide the square root to both sides, so m to the power 8 times the square root of m. Okay, now again 8 is 2 times 4, so I would write this one as the square root of m 4 all to the power 2. So I can now cancel this power with this root. Of course, I would write this again here. Okay, so I left here with m to the power 4 times root m. Okay, same things with part B. Okay. So for part B here, I would just trying to write the values under the root with the power of 3 as a power of 3. So 24, 24 is 6 times 4, and 6 is 3 times 2, and 4 is 2 times 2. So I can write 24 as 2 to the power 3 times 3. Okay, so negative, I will leave the negative. Okay, since the root is odd, we don't have a problem with the negative. So negative 2 to the power 3 times 3, then x to the power 5. For x to the power 5, I will divide it to x to the power 3 and x to the power 2. Okay, since here I have a 3, so I would like to, I need this power. So x to the power 3 times x to the power 2. So now you can divide the or distribute the root if you like. 2 to the power 3, the third root of 3, the third root of x to the power 3, and the third root of x squared. Okay, so this one would cancel this one. Then you're left with negative 2. And for this one also, you will left with x. But for the rest, they will stay the same. So I can put them under one root, it's fine. So the third root of 3x squared. Okay. Next one. We have the third root again of 10 to the power x squared. So the third root of 10x squared over 27 y to the power 6. So the same things, you ask yourself, can you put 10 to a number to the power 3? Of course not. And also x to the power 2, there's no way to have power 3. So I will left the numerator as it is, and then I will work on the denominator. Okay, let's just distribute the root to both the numerator and the denominator. So 27, I can write it as a 3 to the power 3, and y to the power 6 is y to the power 2 all to the power 3. So now I can cancel these powers with the root, and then I would left with 1 over, or the third root of 10x squared over 3y squared. Okay, the last one, the third root of 2 over the third root of 16. Okay, you know 16 is 2 to the power 4. Okay, so what about, since I have here 2, and I can write 16 as 2 to the power 4, so I would like to put both fractions under one, all fraction under one root. So 2 over 16. Now 2 divided by 16 is 8. So this is the third root of 1 over 8. Now 8 is the third root of 8 equal 2, and the third root of 1 equal 1. So 1 over 2. Okay. Okay, now how can I add radicals together or subtract the radicals together? I can only add them or subtract them if I have a similar radicals. What is the similar radical, or what are the similar radicals? The similar radicals is the radical that have the same radicand. Okay, let's see, and same index also. For example, the nth root or the third root of x is similar with the third root of x, and can add these two together, but I can't add the square root of x with the third root of x. I can't add those together. This is completely different, okay? Even if I have here x and I have here x, but I don't have the same root. Simplify root 50 minus root 200. So in order to do that, as we said, we have to have the same or similar radical. So let's try to write root 50 as 25 times 2. So we're going to write root 50 as root 25 times 2. Then we will write root 200 as 100 times 2. Okay, or 10 to the power 2 times 2. Now, in this one, we would, the root of 25 is 5, and root 2 will stay the same. And also, the root of 10 square is 10, and root 2 will stay the same. So the answer would be negative 5 root 2. Okay, this just like taking root 2 as a common factor, then we're left with 5 minus 10. And 5 minus 10 equal minus 5. So minus 5 root 2 or root 2 times negative 5. But we usually write the number before the root. Okay, so we're dealing with the root just like a variable. We usually write, for example, 2x, so it's the same things, 2 root 2. We don't write the opposite way. Okay, for the second one, we have, let me write this down. Z, the fifth root of 64z minus 2 times the fifth root of 2z to the power 6. Okay, so let's see how we're gonna solve this one. So to simplify this one, we have to just have a similar radical. So the fifth root, that means I want to write the under the roots in the power of 5. So 64, you know that 64 is 2 to the power 6. Okay, times z minus 2, then the fifth root of 2z to the power 6. Now for the z to the power 6 and 2 to the power 6, I can write them as z to the power 5 because I need that 5, okay? So I can write divided to z to the power 5 times z, and here 2 to the power 5 times 2. Okay, so let's go ahead and do this. This would be 2 to the power 5 times 2, z minus 2 times z to the power 5 times z. Okay, so all what I have here is just to divide these to a power of 5 times a number. Okay, so now I'm just, whatever to the power 5, I will bring it out of the root. So this would be 2z, then the fifth root of 2z minus 2, then this would be out with z, then the fifth root of 2z. Okay, so I have here the similar root or the similar radical. So all what I have to do is just to subtract the numbers here. And as you can see here, we have the same value exactly. So this value minus the same value would be 0. If I have, for example, if I have here 3z, the fifth radical of 2z minus 2z, the fifth radical of 2z, so I would just minus those together, which is z, then I will put the radical as it is, the fifth root of 2z. So this would be the answer. Okay, let's do this one. We have here the root or the square root of 28. So the square root of 28, we don't know what is the square root, so let's just factorize 28. You know 28 is divisible by 2 with 14, then 14 is 2 times 7. So I can write 28 as 2 to the power 2 times 7. So I will write this as 2 to the power 2 times 7 minus 175. So 175 is divisible by 5 because the ones is 5. So 15 divided by 5 is 3. I will left with 2. 25 divided by 5 is 5. 35 is 7 times 5. So I can write this as 5 to the power 2 times 7. Okay, so as you can see here, I have anything with the power 2 will be out of the root. So here 2, then I will left with root 7, then minus 5 root 7. So I have 2 of root 7 minus 5 of root 7, which means I have negative 3 of root 7. So imagine root 7 is something, okay? So 2 of the something minus 5 of the same thing. So I'm left with negative 3. Or if you'd like just to put the root 7 as a common factor, then you subtract the numbers. Okay. Now let's have this example. Okay. So in this example, the same things, I will try to put the numbers and the variables to the power of the index. Okay. So let's see here. The index here I have is 3. So let's try to put the numbers as a power of 3. So 16 is 2 to the power 4. Okay, so 16 is 2 to the power 4. So I will divide it to 2 to the power 3 times 2. Then x to the power 4, I can write it as x to the power 3 times x. So x to the power 3 times x. So same things here, 4, then the third root of 54. So 54 is divisible, from the times table, you can see that 54 equal 9 times 6, and 9 is 3 times 3, and 6 is 2 times 2. Sorry, 3 times 2. Okay, so 54 is 3 times 3 to the power 3 times 2. So 3 to the power 3 times 2. Then x to the power 4, I can write it as we said here, is x to the power 3 times x. Okay, the third one minus the third root of negative 128. Okay, so let me do this one. So 128, when we factorize 128 with 2, since it is even, so 12 divided by 2 is 6, and 8 divided by 2 is 4. And you know that 64, I just said that 64 is 2 to the power 6. So 128 is 2 to the power 7. Okay, so 128 is 2 to the power 7. So I can write that as 2 to the power 3 times 2 to the power 3 times 2 times 2. Or I can write it as 2 to the power 2 all to the power 3 times 2. Okay, so this 2 to the power 2 all to the power 3 times 2. Then x to the power 4. Okay, then x to the power 4 can be written, as we said, as x to the power 3 times x. Now let's just get the number with the power 3 out of the root. So this would be out of the root, and this one also, this one here. Here we have x to the power 3, and here we have x to the power 2, and this one. So we're just going to put the numbers with root of 3 out without root. So 2 times x, then we put the rest under the root. So 2x plus 4, and here we have times 3x, then the third root of 2x minus 2 to the power 2 times x, then the third root of 2x. So as you can see here, we have third root of 2x, third root of 2x, third root of 2x. So in the result, we're gonna have third root of 2x. Okay, what about the number? So we have 2x plus 12x, this is a 12x, minus 4x. Okay, this is 4x. So 2x plus, this negative would be out of the root, so this would be positive. So negative times negative is positive. Okay, so 2x plus 12x is 14. 14 plus 4x is 18x. So this is 18x. Okay. Okay. When we rewrite a fraction containing a radicals in its denominators as an equivalent fractions with no radical in the denominator, we say this as a rationalize the denominator. بالعربي انطاق المقام. So how can we rationalize the denominator? We just times up and down with the radical. Okay, if it's square root, we get to times it with the square root up and down with the square root. Okay, why we times it with the square root? Because when we times it with the same number, we would have a power of 2, and the power of 2 would cancel the root. So this would be root 2 over root 2 square, which is root 2 over the 2 would cancel, the square would cancel the root, so I left with 2. Okay, let's see the next one, 3 over n. So this is root 3 over root n, so the same things if it's square root, so all I have to do is to times up and down with the denominator. So I left here with 3n. In multiple, we can gather, we can put the root under the product of the numbers, and root n times root n is root n square or n. So root of 3n over n. Okay. For the third one, 4ab to the power 3 over 2a squared b to the power 2. So before we rationalize the denominator, we can simplify. Okay, let's simplify this one. We have 4 over 2, which is 2. And then we have also here a over a squared, which is a in the denominator. And the last one is b to the power 3 with b to the power 2 is b, but up in the numerator. Okay, so now I have the square root of 2b over a, which is the square root of 2b over the square root of a. Let's rationalize now the denominator. So we times up and down with root a. So root a times root a is a directly, or you can write it as this. And then this one times root 2b times root a is root 2ab. Okay. Now we're going to solve this one. I left this one to the end because it has a third root, and it's a little bit different than the square root. So the third root of 7 over 4, the third root of 7 over 4. So let's write this one as the third root of 7 over the third root of 4. In order to have a power of 3, because here I want the third root of 4 all to the power 3. So in order to have this one, I need to multiply this number with itself 2 times, right? So here, the third root of 4 to the power 2. So the result would be power 3. Then I cancel the power with the root. But then in the end, I need to simplify. So just to multiply with the amount of the root, so you don't have to simplify in the end. So let's see. The third root of 4 is the third root of 2 to the power 2. So now I have here power 2, while here I have power 3. So all what I need is only 1, 2 to multiply with 1, 2. This is just like the third root of 2 times the third root of 2. So I need to multiply this. Okay, let me first rewrite it. Third root of 7 times third root of 2 power 2. So I need to multiply up and down with the third root of 2 only. So in the denominator, I would have the third root of 2 all to the power 3. And in the numerator, I would have the third root of 7 times 2, which is 14. So the third root of 14. Now these cancel, the power would cancel the root, and I will left with 2. Okay, so in this case, I don't have to simplify the result. Okay, the result is in the simplest form. I don't have to simplify because I just times up and down with one of the third root of 2, only one time, one of it, not all of it. Okay, all of the denominator. Okay. Now, if we have this form of the denominator, we need to, in order to rationalize these denominators, we need to find out the conjugates بالعربي المرافق. Okay, مرافق المقام. So what is the conjugate of 1 plus root 2? The conjugate of this one is 1 minus root 2. The conjugate of this one is root x plus root 5. So all what you have to do is just to change this sign. Okay, so why we are doing this? Because you remember the difference of two squares. So the difference of two squares, if you have root x minus root 5 and then root x plus root 5, you just put the first one square minus the second one square. And since the first one square, okay, this is the first one square, minus the second one square, the first one would cancel the root and the second one would also cancel the root, and that's what we want. This is our goal, to get rid of the root. So I would get the answer without root, and this is what I want. So that's why here I need the conjugate in order to do rationalizing. Okay. Okay. So as you can see here, this one, 1 plus root 2. So I times up and down with 1 minus root 2. So in the numerator, I just have a 1 minus root 2. And in the denominator, I have 1 square minus the second 1 square. Okay. And you know 1 square equal 1. And root 2 square equal 2. So 1 minus 2 equal minus 1. Okay. So now, what is how this one gets to this shape? So the reason here that I multiply the numerator with the negative. So negative 1 minus root 2. So it is negative 1 plus root 2, or just I switch the places because this root 2 minus 1. Okay. So same things here. I have root x minus root 5. So I times up and down with root x plus root 5. And now the numerator is the same. And the denominator is root x square, which is x. Then minus root 5 square, which is 5. Okay. So in general, if I have... as I said, the nth root is just a form of an exponent, which is 1 over n. So I can write the nth root of x as x to the power 1 over n. And if m over n is a fraction in the lowest terms, okay, where m and n integers and m is more than or equal to, so in this case, x to the power m over n is defined by x to the power 1 over n all to the power m, and then I write the 1 over n in the shape of the root and leave the power m as it is. So it is flexible to deal with the root as a power of 1 over or just to put the form of the root. Okay, so evaluate the expressions. As you can see here, the 4 to the power 5 over 2. So since here 5 over 2 is just 1 over 2 times 5, and 1 over 2 is a square root of 2 square roots. So this I can write this as square root of 4, okay, all to the power 5. Okay, then the square root of 4, you know, it's 2, so 2 to the power 5 equal 32. Okay. Okay, the next one. Negative 8 to the power 4 over 3. So 1 over 3 can be written in a root form of negative 8. Then power 4 is same, it would be power 4. And we know that this values is negative 2 and power 4, I will leave it. Then I will find out the negative 2 of power 4, which is 16. Okay, for 32 to the power negative 2 over 5, so same things, I will divide this one to 1 over 5 and then 2, or negative 2. And then 1 over 5 is the root, the fifth root of 25. And you know that the fifth root of 32 is 2. Then I put the power as it is. The negative power, it means I will just flip. So 2 to the power negative 2, this would be 1 over 2 to the power 2. And 2 to the power 2 is 4, so 1 over 4. For D, we have a 25 to the power 6 over 4. We can simplify 6 to the power 4 to 3 to the power 2. And then 1 over 2, the power 1 over 2 is the square root. So the square root of 25 all to the power 3. And you know, the square root of 25 is 5. So 5 to the power 3, which equal 125. Okay, so this is the rule of the exponent, okay, and there's just summarize for the rules of exponent. If we have the same base, we can add the power. In the times or in the division, we can subtract the power. If we have power raised to another power, we can multiply the power. And if we have a power of a product, we can have the power in each factor of the product. And also here, it seems like we distribute the powers to the multiplication and to the division. So let's have these examples here to apply these rules. Okay, for the first one, we have these values to the power 6. So we can just distribute 6 to the numerator and the denominator, the first step. The second step, we have this power is raised to another power, so we can multiply the powers together. Okay, so negative 2 over 3 times 6. We can simplify this one with this one, so I would have negative 4. Same things, I will multiply these two powers together, so negative 1 over 2 times 6, which means half of the 6 is 3, so negative 3. And also I will multiply these two powers together, so I would have 5th times 10th, which is negative 2. Now I have x and here another x, so I can add the powers. So I would add those powers together. So negative 4, negative 2, which is negative 6. So x to the power negative 6 over y to the power negative 3. We usually prefer to write the powers in a positive integers. See? Positive. So if it has negative integer, we will write it up y, and x has negative, so we will put it down with a positive power. Okay, for this question, same things. I will first distribute the 1 over 2 to each factors. So 16 to the power 1 over 2 x to the power 3 to the power 1 over 2, y to the power 1 over 2. Okay, and same things here with 1 over 3. So I'll distribute the 1 over 3 to all the factors, 1 over 3. And now I will, here I have power to power, so I will multiply. So I would have, for this one, 3 over 2. So x to the power 3 over 2. The power 1 over 2 means the square root of 16, which is 4. And also this I can write it as the y to the power 1 over 2. Here I would multiply 3 with 1 over 3, which is 1. And here 2 with 1 over 3, 2 over 3. So I will left with 4 x to the power 3 over 2, y to the power half over x to the power 2 over 3y. Now I will just simplify the similar terms together. So this x together and y's together. So I will left with 4, then x to the power 3 over 2 minus 2 over 3, and then y 1 over 2 minus 1. And you know that 3 over 2 minus 2 over 3 is 5 over 6, and half minus 1 is minus 1 over 2. So I can put this one down because it's negative and leave the rest up. That's all for this video. Hope you enjoyed. Thank you.